this is an interesting integral that we could solve in a different way. We'll start with 1 minus x like this, and then that's equal to 1 plus x squared, and then this would continue. If it's so xy though, then we could say that it would be something like this, y squared, and then x to the third, y to the third. Now we could do the integral. So we'll go like this, 0 to 1, 0 to 1. This would just go across everything. And this is 4 dy will go on the first time. So we can go ahead and just go y plus y squared x over 2 plus y to the third x squared over 3 plus y to the fourth x to the third over 4. This is going to be going from 0 to 1, so we could plug this in and we get 1 plus x over 2 plus x squared over 3 x to the third over 4. And then the 0 will just cancel everything out. We'll go from 0 to 1 over dx now. We could solve this one by saying x plus x squared over 4 plus x to the third over 9 plus x to the fourth over 16. This is going from 0 to 1. That'll be 1 plus 1/4 plus 1/9 and 1/16. So we can see that this is going to be the sum of 1 over n squared, as n goes from 1 all the way to infinity. And this would be written, could possibly also equal x squared over 6. So that's one way we could solve this. A more intense way to solve this problem would be to make a replacement. You could say x equals u minus v and y equals u plus v. And so you could rewrite this thing saying that you do a double integral and then 1 divided by, well, you'd have to multiply those things out. So I suppose we could do that here. U minus v times u plus v. Well, that would just be u squared minus v squared. So it's kind of like 1 minus u squared. But it would be like kind of in parentheses like this. So you basically get a plus v squared essentially. But anyway, you also want this du dv situation. So let's try to do that. Let's go with dx equals du minus dv, dy equals du plus dv. So we'll get the little matrix dx and then dy on the bottom here is going to be equal to 1 minus 1, 1, 1. And then you'd have the du and dv here. So this will just be equal to 1 plus 1 equaling 2 du dv, and then there would be a dx dy on this side. So you kind of have to make this replacement. For dx dy, you're going to put 2 du dv. And I think we will be putting du on the outside for this particular problem. We have to make a transformation between one and the other. This one's going to be the x and y, and this one's going to be the u and v. So for xy, it's going from 0 to 1. So that means 0 to 1, 0 to 1, and then there's really no equation, so it's a box, giving us the coordinates 0, 1, 1, 1, and that's actually 1, 0, and this is 0, 1. Okay. So now over here, let's try to rearrange these equations that we have, because we want u in terms of x and y. And we could say u equals x plus v. And then we could also say that v equals y minus u. So that way u equals x plus y minus u, meaning that u equals x plus y, and then I'll just add the u over here, so the 2u, and then I can divide this by 2. So that way I get u equals x plus y over 2. And then I could sort of do something for the v. I already know the u, so I could say that v equals y minus x plus y over 2. And I'll go ahead and do like v equals 2y over everything 2. Here's the x plus y on top. So we'll basically just get v equals y minus x over 2. All right. So that means that now I can try to make the transformation with these couple of points that we have here. We could sort of say like 0, 1, what would that go to? We know 0, 0 is going to go to 0, 0, so let's not worry too much about that one. 1, 0, and then 1, 1. Where are these going? Well, if x and y are 0, 1, then u is going to 1/2, and the v is going to 1/2 as well. And then for 1, 0, well, 1/2 for that one. And then for this one, it's actually negative 1/2. And then over here, 1, 1, that gives us 1. And over here, we get 0. So now we've got our new points. We'll have 1, 0. And I'll actually make that a little bit larger because we have halves coming up. So here's the 1 mark. And then there's a half. And then there's a negative half. And then there's going to be a half and a half. Let's go from there to there. So now we have our new thing. And if we want to make this line right here, there's a whole bunch of lines. So we got to be kind of careful about these. I'll try to draw a little bit of crisscrossing, but not too much. So because we're going, and the u is in the outside, then we care about the u's. So we're going to go from 0 to 1 directly on the u's. We'll try to set this up. And we know that we're going to want to try to split this in half because we got so much stuff going on. We could literally split it right down the middle. So we'll go like this. And we'll have 2 integrals set up. So on the first side, we're going to go 0 to 1/2. 0 to 1/2. And on the second half, we're going to go 1/2 to 1. 1/2 to 1. And this is for when we would have 2 dv and then du is on the outside over 1 minus u squared plus v squared. And then over here, you'd have the same exact thing. We're just sort of getting set up. We're going to add those two things together. Now we just need to get the v limits. That's going to be on the inside. We're almost done. Because right, we're going from 0 to 1/2 and then from 1/2 to 1 on the u limits. These are on the outside. So all we need is the new v's. Let's see. Well, on this side, the v's are basically going from here to there. Because we're kind of going to expand this way. So we care about this line, which is this one, and we care about this line. I didn't really do this on graph paper, but if you did, you would see that this is certainly a graph of v equals u, and this one is v equals negative u. So that's what we'll put in over here, negative u to u, which if we so wanted, we could definitely put that as 0 and put a 2 over there somewhere. Because it's symmetrical, as you can see. And then on this side, we care about this line, which intersects over here at the 1. So this particular line on top is actually v equals 1 minus u. And that's going to be on the other side, we would have the line, let's see if we can get some space in there. On that side, the line would be v equals u minus 1. So that's what we're going to go from on the second half for our v values. We'll put this over here as u minus 1 and 1 minus u. And because it's symmetrical, we'll go ahead and put that as a 0, multiply this by 2, and we have our new integral, which is kind of harder than the previous one, but hey, you know, it is what it is.